Okay, we're going to have a quick look at denaturing of proteins and how this occurs, and specifically we're going to have a look at how it occurs in enzymes. So first off, let's just start by reviewing our protein structure. And our protein structures in our primary structures are made up of these amino acids joined with peptide bonds, and they're joined, each one of those amino acids is a monomer making up the big polymer of amino acids. That's our primary structure. Our secondary structure is the folding in beta-pleated sheets, or our coiling in our alpha helixes of this primary structure. Okay, so getting this long line of amino acids and either folding it up or coiling it, and that's done by regular hydrogen bonds in between this strand in the primary structure. Next we move to the tertiary structure, and this is where we get the complex three-dimensional shape that is quite characteristic of all proteins. We have disulfide bonds occurring between various points that hold it in that shape, and also some hydrogen bonds as well. So that's a tertiary structure, and the quaternary structure is when we put a couple of these units in the tertiary structure together, so join a few bits of protein together. And this is a structure that we have in enzymes. And here's an example of some different enzymes, and we can see that each one of them has quite a complex shape, that they look significantly different from each other. And that's what's giving that shape specificity. And this is really important because this is the shape and the difference that we're getting in the active sites of enzymes. They're specific, they only work for particular substrates because they're the only ones that fit. Okay, so let's move on to denaturing. Now, what's happening in denaturing is, if we revisit our structure a little bit here, these hydrogen bonds in the beta-pleated sheet or alpha helixes can be damaged. Or the disulfide bonds can be damaged. And there's a few different ways that this can occur. It can occur at very high temperatures. It can occur at extreme pHs, high or low pH. And other chemicals can also do it. And when the other chemicals come in contact with the protein, it allows the molecules just to arrange themselves a bit different. It causes a disruption to how the molecules would normally set themselves up. Okay, and any disruption to chemical bonds in this molecule can have a pretty big effect on its shape. So looking at that, here we have the process of denaturing, and we can see that we have this specific three-dimensional shape, whereas here we have a lot of those bonds breaking down, and when those bonds break down, the molecule more or less unravels a little bit, and we have a strand, and that's more often than not irreversible. Okay, it occurs in one direction, and it's very difficult without making the protein again to get it back into that shape. Okay, so key points today: denaturing is when the bonds that hold the protein in its three-dimensional shape are broken down, and it's often irreversible. Occurred by high temperatures, not by low temperatures, only by high temperatures and extremes in pH or other chemicals. Okay, good luck with looking at denaturing of enzymes.